Hello, everyone, and welcome to the AI Beyond the Hype panel. We cannot really see you, but okay. Hope you're all there. Um, and we're here to separate fact from fiction today. That's why we're calling the panel AI Beyond Hype. And what I call a whirlwind discussion around LLMs today. Because on one side, they're being praised like this holy grail of automation that are promised to revolutionize every industry by thinking like the humans, coding, writing, doing everything that we do. And then on the other side, we have the skeptics that dismiss this technology, labeling it as glorified autocomplete that will never be able to help us in any way. So that's why I'm saying that we want to, our goal for this session is to cut through these extremes and get to what really matters when building responsible AI systems or incorporating AI in our work. But first, I'll turn to my friends here. Just if you can briefly introduce yourselves. Vlad, you go
Okay,
first.
so we're gonna start from here. All right. Hello, everyone. I hope you all had a good lunch and a sip of coffee, so now you're ready and energized for the remainder of the day. My name is Vlad. I'm the CDO of a company called StrongBytes. I'm a technologist at heart, and probably like many of you, a couple of years ago, I jumped the Gen AI LLM bandwagon, and I've been building products using these technologies. I've been learning and reading about them. I've been consulting for clients. And I also tried to understand more about these technologies through the lens of, other possible intersectional subjects like, psychology and cognitive sciences and philosophy. So I really hope we're gonna maybe touch on some of these interesting topics, and I'm looking forward to having great conversations.
Right. My name is Mark Richards. I'm a hands-on software architect, author, and also the founder of developer2architect.com. And I've been involved in AI for quite some time now.
Hi, my name is Neal Ford. I work at ThoughtWorks. I've been at ThoughtWorks a little over 20 years. That was my anniversary back in April. And part of what I do at ThoughtWorks is help put together the ThoughtWorks Technology Radar. And the reason I tell you that is because I'm foreshadowing the answer to the first question that was going to be asked in just a few minutes. This is the after lunch session, so we made sure to make it nice and dark in here, and we'll be sure and speak in a nice low tone of voice. So if you want to get a quick nap after lunch before the next session starts,
This is the right place to be. We should have put that on the door.
I fill up the room.
All right, so let's jump into the first question. I have to warn you guys, it's a sort of a fill in the blanks thing. So here it goes. The most dangerous assumption when building AI systems is.
We do the same round, right? Okay. So the most dangerous assumptions when building AI systems is, I think, the fact that the test set metrics will generalize the same to the real world data, meaning that you're going to get the same degree of accuracy and bias and hallucination and so on and so forth. And I think that's just not true, because LLMs are trained on a huge corpus of data, of course, but that only represents only a subset of the possible questions that a user might ask. So just the sheer combinatorics of human knowledge means that you can ask any kind of question that the LLM was not trained on, or it was not part of the training set. And I just don't think that scales as well. And just to end this bullet's answer, I'm going to say that the great things about benchmarks is that they exist, right? Because we need an actual way to be able to evaluate something, track progress, make sure that we're going into the right direction. But the bad thing about benchmarks is that they exist, because they actually can convey this false sense of, performance that will not necessarily apply the same to the real world. So just treat, benchmarks and results, and this is like the new PhD level assistant kind of thing, communication that you hear from the outside, but a little bit of caution.
Thank you. Mark?
I don't remember the question. No, I'm kidding. The most dangerous assumption is to assume that generative AI is deterministic. and this is a very dangerous assumption. It's easy to get into this trap. Always remember, generative AI is non-deterministic. We can't guarantee to get a consistent or correct answer. This makes it very challenging when we're trying to build AI-based applications.
Well, in the nature of panels like this, I'm going to change this from a one fill in the blank to two fill in the blank. The first one is sort of related to what Mark was talking about, anthropomorphizing AI. So I'm part of the ThoughtWorks Technology Radar Group, and that's where most of my knowledge about AI comes from, is the experts in that group that I'm part of. And one of the things that we put on hold on our radar is anthropomorphizing AI. The statistic just came out recently that the amount of money that ChatGPT spent was a number with the billion behind it, parsing please and thank you for the LLM. You really don't have to tell it please and thank you. It's not really there. And the other,
Are you sure about that, Neal?
so we'll
I'm not taking a chance.
We'll
Yeah.
talk about Pascal's
Candid in the future.
later at Gen AI. But the second one is something that I recorded a podcast about recently, which is vibe coding. This mistaken assumption that the details don't really matter. I can just vibe my way to some sort of solution. And the two interesting things about that is the exemplar that everybody points to. I think it took less than a week before our major security and other problems showed up in his vibe-coded little solution. But the other interesting thing is how fast semantic diffusion happens in the AI age, because he made this sort of harmless little post about enjoying a flow state, and everybody in the industry grabbed it and applied their own meaning to it and ran like crazy with it like a thunderstorm. So we're going to see more of that, I suspect.
Vlad and I had dinner a couple of weeks ago with a friend, Michael Bolton, and he said that, yeah, it's also a concept of vibe testing. So I'm just going with the flow. It works, bro. Don't worry.
So vibe next to anything, something will pop up.
I'm going to do a vibe dinner. Anybody want to join me? I don't even know what that means.
So then, I thought you'd want to say that the most dangerous assumption is that LLMs are truly intelligent. Is that the case? Can they display human intelligence, or is this a rabbit hole asking us what this intelligence means?
Well, it's interesting. What divides us humans from all the rest of the species on this planet are four things. It's the ability to think, the ability to learn, the ability to communicate, and the ability to control our environment. That is truly what separates us from any other species. And when we start to think about this human intelligence, and is AI really kind of human intelligence, I always come back to this kind of definition. Can it actually replace a human? And while AI may be able to, quote, think, I don't know. That's a good discussion topic. Whether it can actually communicate, well, I think it can. But the other aspects, I'm really not sure. You're right, it depends on how we define intelligence, but with that kind of definition of what makes us as humans special, AI doesn't even come close to that yet.
I think AI is like a talking dog. It's like, wow, that dog can talk. It's like, well, he speaks gibberish. Yeah, but he can talk. Because it's so good at language, it mimics intelligence, but there's no intelligence there. It's just pure pattern matching. What it makes me wonder is how much of our language is actually doing what the LLM does, which is just predicting what the next word should be. Because that's all the thing is doing. It's not applying any reason or logic, or it's just, so it turns out that what it's returning you are things that are statistically likely. And it turns out that many things that are true are statistically likely, but not everything. And that's the trap you fall into, is that, oh, it must be thinking, it must be intelligent. No, it's just giving you statistically likely answers until something comes up that it's never encountered. So.
This is a good example of if it quacks like a duck and walks like a duck. Actually, this time it's not a duck, right? So there's this guy, Bloom, who kind of like back in the days, I think in the late 70s, invented a taxonomy for the entire cognitive space of how humans operate. And it's kind of like divided into 6 parts. The first layer is called memorization. Then we have understanding, then we have applying, we have analyzing, evaluating, and in the end, creating. And what happens is that if we look at LLMs and what they do today, they're actually really good at the first level, right? They're good at recalling information from the training set that they've been trained on. They know how to do that. They do that at scale in different domains, in different industries. They're great for that. They're great for that, knowledge, recollection in the moment, but they have no ability to truly go beyond that level. And humans do that, and they do it in so many different ways rather than an LLM, because when we reason about things, we don't do it by generating words in our head, one by one in a sequence, which is what LLMs do. We have so many other different ways of reasoning and thinking about things. And it's just, this is a great piece of technology, but it's just scratching the surface of, what it means to display that human level intelligence. But it's a great step, or a great initial first step into that route.
So you're saying that right now AI is essentially a baby, a newborn.
Yeah, kind of like an infant.
Kind of like an infant. Yeah, an infant.
It turns out that infants are actually born with some priors, and AI doesn't really have that. Like, we have an innate ability to understand counting. Like, we know that 2 is greater than 1, even if we don't know that, what 1 and 2 actually means. We have an innate understanding of the physical world. We're able to identify agents and actions in the environment, even as newborns, as infants. And all these things, although they're very simplistic and they seem like, wow, of course, this is very intuitive to us, they're hugely influential in us learning about the world initially and gaining that knowledge. So AI doesn't have that, and we don't really know of a simple and easy way to encode it, actually.
So in the end, it is a glorified autocomplete, especially if I'm looking at what Neil said, but then it is trained on the whole internet. So that means something. But since we're all here involved in software development in one way or another, there's a question of using LLMs in the way they are for generating code. Neil, how good is that code? Will AI replace programmers in the nearby future?
Well, it's really good for small, narrow problems that have been solved a lot. In fact, the more the problem has been solved, the more likely you're going to get a statistically correct answer, because the corpus it's pulling from is much broader. So you'll never have to wonder again, how do I configure Kubernetes? Because that problem's been solved a gajillion times in the web, and so he can easily tell you how to do that. That's why it's so bad at problems that have never been solved before, because then it gets into guessing and hallucinating and that sort of stuff. But for narrow scale problems, in fact, that's where we've seen the most advance, at least for the surface area for most of us, are in. So originally we had Copilot, originally we had IntelliSense, and helping us with APIs, and then we got Copilot, which is generating code, and now the next generation are these agentic tools like a Cursor that can now manipulate multiple files at a time and generate shell scripts, and that always makes me pause, because I remember the Sorcerer's Apprentice and the Brooms, because I at least come from a generation where I've at least wiped out at least one hard drive by mistake in a shell script that was a little too broad a scope, and letting AI loose with a shell script on my operating system. I mean, I know it asks you before it does it, or is that okay? But you're going to get really used to just saying yes all the time. You're just going to default to yes, and it's going to be one of those things where it's like, yes, oh, wait, and then it's too late. But I think that's where we're seeing real advances on a day-to-day basis, is the agentic stuff. And I think that's going to incrementally get better and better, because, again, we're talking about a narrowly scoped problem that has a giant corpus of solutions out in the world. The thing that I worry about, though, this is the thing I predict, is that as developers and architects get ready for a tidal wave of functioning but terrible code, because generative AI, when it generates code, it uses brute force. It doesn't think about abstractions and design patterns. So I believe the other sort of day-to-day impact for us is that developers are going to quickly move from writing code by hand to refactoring generated code. And we already see a lot of evidence of this over the industry over the last 2 years. Pull requests have gotten more than 10% bigger on average. That's the effect of generated code and brute force approaches. And so we're soon going to have to start fighting the tide of drowning in too much generated code, because it makes things hard to understand.
Did spreadsheets replace accountants? No, they did not. They allowed them to be more creative and do more work because that menial stuff of adding numbers together was done through a tool. And so that's how I visualize code generation through AI in terms of a great tool for the menial kind of tasks that we face as developers. This question I have been asked for almost a year and a half now. And in my journey and in my tours of clients and classes and conferences like this, I always ask, on average, how much time as a developer do you spend actually sitting down coding? And across the board, that number is generally less than 30%, sometimes less than 20%. And so if you think about all the other activities we do as developers, coding is just one small part of all that. And so I don't think it will, but I do also have a little bit of a scary prediction in the future. If we start replacing junior developers, now I'm starting to get all excited. If we start to replace junior developers with menial tasks, with Copilot, with any sort of generative AI to generate that code, let me ask you a question then. Where are our senior developers going to come from? We're going to run out of them. And this is a really scary proposition if you think about it. So remember those kind of little predictions and kind of supply chains, because we have the opportunity here of possibly breaking that supply chain. That's a little scary to me.
So all those developers are only coding 30% of the time. They'd rather be coding more of the time. So can we get AI to go attend meetings for us so we can code
That would
more?
be great.
What an
That
awesome
would be
idea.
useful. That's what we need.
Attend the stand-up.
Forget about Copilot. We need co-meeting.
Co-meeting, yes.
All right, so, but what are we doing in the rest of the 70%, Vlad?
Meetings.
Okay, yeah, probably meetings. But the good thing is, these tools and these technologies, yes, they can tackle like very simple tasks very efficiently, but that's actually useful, right? And I really hope that by incorporating them, people are going to have more time to think about all the other things that are part of the software development, let's call it job description / things that you do on a daily basis, which go way more beyond coding, right? Because there are so many things you're going to be able to do. So if you now manage to free a little bit of time because you know how to efficiently use these tools to help you in the development process, and I think that's easier for seniors to implement and to immediately take advantage of rather than juniors. But I think the learning rate for juniors is something that you can easily take advantage of with such tools and systems. So you're going to have more time to do other things. So maybe now you get a little bit of extra time to think about that architectural decisions that are down the road. Spend more thinking time into how you're going to approach this problem, come up with a new suggestion for a feature for your client, go and mentor that person, that's struggling in your team, communicate something to your client, make sure that you keep all of those things up. There's so many things that we do as developers, and I really hope, these things being easier to tackle with technologies such as Gen AI, the code generation part, will allow for better productivity overall, because you're going to get more time to focus on other things that are at least equally important.
I want to call back to one of the things you just mentioned in that statement, and the importance of this, because what you mentioned, Vlad, was increasing our thinking time. How often do we, as developers, get the opportunity just to sit down and think about our problem, think about the feature we're trying to implement, with the best way of possibly designing that feature? And when I say design, in terms of the number of classes, what kind of classes, should I use inheritance, should I use encapsulation, all these kind of design aspects of implementing a particular feature. We don't. And I love what you just said, because that's one of the important aspects of, well, what am I going to do with my time? Think more. That is awesome, because that is a valuable thing that we don't have much time for.
Well, one of the things that what I used to teach a lot of hands-on classes and pure coding, one of the things that used to frustrate me as an instructor is when someone would get an error and they wouldn't think about the root cause of the problem. They'd just randomly change something and try it again.
Yeah.
And that used to drive me crazy. Stop. Now, there's a reason why this is yelling at you about this, but things like vibe coding or chat-oriented program just makes that so much worse because I have no idea how that works. But let's just try it again and see if the non-determinism will fix it this time. But you're just building a mountain of stuff that you have no way of understanding, and then, that's what could go wrong.
Oh, my word. How many times have all of you that use Copilot say, not quite. Can you regenerate that for me a little differently? Sure, here. I kind of don't like that. Can you This can go on for months, everyone, depending on the number of vector matches you're getting. I just immediately thought of that because I do that as well.
All right, I agree with you. I agree with you. But then you cannot, tell ChatGPT or whatever your favorite LLM is, build me an invoicing app. Right? And my question is, but what's the right level of abstraction or granularity where you would ask things from this?
Well, do all of you remember the golden rule of development or even architecture, but I'll just put it into development, which is always work one level of abstraction lower than you're at. And this is a very useful kind of thing. But I just want to briefly answer this. I'm not going to fully answer it, but I want to show a little anecdote to demonstrate this. Dan and I were talking about different interview questions and stuff and having fun. And here's some of the questions in a developer interview that I throw out. Oh, that's great. Okay, so the design, how would you actually change the color of this? How many bits in a byte? What? How many bits are in a byte? And how many bytes are in a word? And how many bytes are in an integer? Now, if you're coding in something like C or C++, I really do expect an answer to that because that is one level of abstraction lower than what you're coding in. We have to know that for memory management. But if you're coding in any other language, we don't need to know this anymore because it's further down in the abstraction layers. And I'm not sure how I feel about this because I do think every developer should know these basics of computing. But is it really necessary that we know those basics? Because we don't use them anymore.
I think knowing the basics is probably a proxy indicative to, someone that has critical thinking or displays critical thinking or a certain, ability to understand what happens behind the scenes, even though they're not necessarily or immediately useful in certain languages. I just think that, the art of kind of like working efficiently with LLMs and bringing them efficiently into your day-to-day basis is basically this dance of properly navigating the abstraction ladder with instructions and generation of whatever code ideas and etc. And you as a person, as a human, as a software developer, you're still going to be the one responsible of doing all the high-level thinking and reasoning and doing all the breaking down of problems into smaller things, and knowing at what point you could start to use this particular LLM efficiently. And I suppose some of that will also kind of like come with experience and with playing with this, but you're not going to ask like a very high-level question and expect a good answer like, how would I build this architecture for the system, or build me that invoice app or whatever. That's a bad way of prompting it. But you're also not going to probably deconstruct everything down to the lowest level possible and say like, hey, now create this function for me that adds 2 numbers, because you're probably going to spend more time prompting than it would take to write your code. And so you're going to navigate this. And I think this is slowly starting to become a skill, right? It's people are going to learn this by experience.
So one of the pervasive questions we keep getting is from employers is AI helping or hurting? And that's why there's an obsession about measuring developer productivity, which has always been a slippery thing to try to measure. Martin Fowler has an entire blog entry about how fruitless it is trying to measure developer productivity. There are actually some tools like the things that Spotify have created that are actually measuring useful things like how long you spend in flow. But that's why there's an obsession about measuring productivity, because what managers fundamentally want to know is that, okay, used to, as a developer, oh, I'm trying to get this to work, so you spend an hour Googling something until you finally come to a solution. Well, you don't have to do that anymore. Now you spend an hour and a half with ChatGPT telling it to regenerate over and over and over again until you get just the right thing, and the one that captures your sense of coding just right and the personality, which is better or worse. And so there's still a fundamental question that's at large about that. I think that the agentic coding and the incremental advances we're seeing there is in fact helping the productivity, because it's enabled to do more and more stuff and require less and less attention to broader scoped problems. And I think that ultimately is the answer to your question. We're seeing broader, the applicability get slightly broader, multi-files, file system, so I think it's going to creep a little bit broader, not all the way to build me, a desktop application, but more and more scope around behavior.
And kind of pointing more to the question, I think it's more of a focus on the categories of the AI ecosystem, as opposed to going deeper into how each of those products actually work. That is overwhelming enough. Tell us, Neal, how many categories and products are in the radar?
We had, for the most recent edition of the radar, almost half the entries were AI related, so 50 something out of 110, so a lot of things.
So are you still having the meetings for defining the technology radar, or
Yep.
just ChatGPT will spit it out from now on?
Nope. We thought about that and then rejected that out of turn. But yeah, Bangkok was the last meeting, and the next meeting is going to be in September in Bucharest.
Nice.
Yay. Well, how many of you remember before microservices, before Kubernetes? Awesome, fantastic. Do you remember that world? There were 15 to 20 different categories of products for operational automation, and a lot of them didn't play nicely with each other. And this was just a folly, trying to figure out what products I need from which kind of category and capability and bolt them together and try to make them all work in the ecosystem. I can't help but think, anytime I look at the number of categories of tools available to us as developers now, I keep going back to, we are pre-Kubernetes. The Kubernetes basically brought us a consolidation of all of these kind of various tools in a single platform. So I didn't have to go out and evaluate 12 different service discovery tools and such. And that was amazing. It, by the way, did not reduce our time, because it takes 4 months to configure Kubernetes. But at least it made it a little easier in terms of the evaluation of everything. This is what I see a transformation happening eventually in this industry right now. Because like Kubernetes, we're going to say, why do we have all these tools? Evals and guardrails are both, we need both of those. Why don't we make a platform to handle both of those at the same time? And so I think this question about how much do we need to know will change as we start to progress towards getting rid of these Lego blocks of products and more towards evaluation platforms instead of evaluation tools.
Yeah, but I think that commodification is a long way off. So I've actually been involved in all 32 editions of the radar except one that I happened to miss that meeting. And it's been interesting over time, because you see this sort of expansion and contraction. So there's an entire category of platform stuff that included all the things you were talking about, and then that kind of faded away, and then the JavaScript stuff went crazy for a while. Everything was JavaScript, and there was just so much JavaScript
I
stuff.
think
It was
you're
chaos.
going to touch a
Same
nerve
thing,
here.
like the churn that happened at a certain point in the ecosystem. Just every single day there was a new framework, a new library, a new something.
But now that's really calmed down. But
Yeah.
now I think the AI stuff is on the uptick.
Yep.
I don't think we've hit anywhere near the peak. I think it is, and a great example of that is one of the themes of our most recent radar is the R in RAG. And so the retrieval part of RAG suddenly has all this innovation and hotspots and technologies, and we're going to see that in all these little hotspots, because there's so many different places in AI where sudden bursts of innovation are going to happen. So the next radar, it's going to be some other part of the ecosystem. We're going to continue seeing this bursty fireworks effect until we finally get to a point where you can start making commodities out of these things, but that's going to be a while, I think.
And by the way, 8 bits in a byte, 2 bytes in a word, and 4 bytes in an integer. Unless you're in a 16-bit operating system, then it's 2 bytes per integer.
No,
there
Mark,
you go.
your question should be how many tokens in a paragraph?
Oh,
That's
yes,
the
now.
next question.
Oh, there you Oh, I love that. Yes, how many tokens in a paragraph? That's what it's going to boil down to. This is scary. Oh.
All right, so I'm conscious of time a bit, so I'm going to split up the next question. So, and ask, actually it's the same question, but I'm going to ask it from different perspectives. So I'll turn to Vlad first. So what are some of the struggles that developers are facing when, I don't know, in regards to incorporating AI?
Okay, so one thing that immediately comes to mind is what was kind of like also briefly touched upon by Mark and Neal, but the churn of the ecosystem and basically the entire evolution of it is amazing. It's very fast-paced. It's hard to keep track of everything. It's hard to kind of like make sense of everything. You don't really know what's the best tool for this, for that, and you're going to have to spend time like integrating and understanding and combining various, various parts from the ecosystem into some sort of coherent end-to-end process. And I also think that, in terms of on the DevOps side, a couple of things have changed, because I do think that the classical, DevOps patterns with all the CI/CD pipelines now need to incorporate and think about all the ML assets, for example. Like, now you have to think about setting up experiments and doing experiment tracking and, doing model versioning maybe, and the ability to roll back and have some sort of way to monitor all the, let's call them silent failures, like the biases, the drifts, the toxicity, the hallucination, all of those things, which are not easy to measure. So there's an entire challenge, I believe, there that touches more on the DevOps side. And these are some things that are coming as new problems, and they're on the plate of software development teams and people, individuals, and teams as well. And we just have to tackle them. I suppose some solutions will emerge and maybe consolidate, as you were saying as well. But in the meantime, I do believe that these are struggles.
All right, cool. Duly noted. Mark, how about architects? You would focus from that perspective.
Oh boy, so challenges and struggles architects face. I think one of the struggles is trying to unravel what part of the generative AI ecosystem is relevant to me. Because there are certainly tools and categories that are very relevant as a developer, but don't change the structure of a system. I find this, especially myself as an architect, quite overwhelming. Because I'm not sure which categories I should actually focus on. Actually, I do know, but we'll be getting to those hopefully in a little while, evals and guardrails. Those two do change the structure of a system. But also, I think one of the other challenges is cost. Myself as an architect, am responsible for ensuring the success of this implementation, which includes time and budget. And cost is multifactored. Cost in terms of actually making calls, but also cost in terms of providing the infrastructure, especially for a private LLM. And as a matter of fact, that would be a third challenge and struggle, is the assumption that, we'll just train our own LLM or SLM, which is a small language model, something that's more targeted, specific to my context. That is hard. Extremely hard and extremely costly. And I think that's one of the things we, especially as architects, tend to minimize when we add that into our solution space. So those would be 3 things I would answer.
Cool. So then we actually need to know bit about the AI ecosystem.
What's that? Oh yes. But you know
Yes,
what?
yes.
I have to answer a 4th one here that just came to my mind as a huge concern, and it has to do with cost. And that's just the whole sustainability, energy aspect of LLMs. Neal, how many billions of dollars and billions of kilowatt hours were spent with please and thank yous? I still do that, but I'm not going to anymore now that I have this knowledge in mind. Let's save the ecological part of our world. Because the more we start using LLMs, the more we're going to just actually destroy our world. We're going to run out of energy. And so this is yet another concern. Now, as an architect, I'm more concerned about the cost and the training and all this kind of stuff. But it is a concern that I think all of us, developments all the way up to companies, should be concerned about.
I don't. My mother always taught me to say please and thank you, so I still do that with the.
You can also
LLMs.
climb the tree with the time that you save from coding, right? So about the things that you can do.
I like that.
Neal, what about if we go one level higher than maybe two? What about teams or companies? What are their struggles?
Figuring out the applicability. Is this going to make us more productive? Is this helping? Is it hurting? I mean, that's a big one for teams. You know, how are we going to use this and actually, you know, make use of it? But companies are also thinking, how do I incorporate this into chat? And, you know, last thing you want to do is release a chat bot for your company and it start insulting everybody a lot. And it's like, hey, no, let's not do that. But, you know, they're non-deterministic. So who knows, you know, what path they may end up taking. But related to what Mark was saying, I think a lot of companies who are paying attention are very worried about this. All of the LLMs that are charging money for subscriptions, they are working on the Silicon Valley business model, which is work at a loss until you capture a market and then you raise the price. And they're all operating at a crazy loss right now. I mean, that's what they're using all this massive investment money for, is to burn through it all, giving you cheaper than cost access because they want to get you hooked, and then when they get you hooked, they crank up the price. And I think enterprises are super worried about getting their teams, their developers, their architects, their QAs, everybody in the company super addicted to LLMs, and then suddenly that price starts ratcheting up, and suddenly we're talking about a big cost center for a lot of companies. And, you know, there's a constant balance between what is it costing us versus what value is it providing. And that equation is going to keep changing as the businesses change for these things, as one tries to compete with the other. So I think it's wise for companies to think about, okay, what are we going to be doing with AI in 2 years, but what does the 5-year outlook look like? What is this going to cost in 5 years, you know, and what kind of capabilities but cost? And so I think that's really worrying a lot of the accounting types.
I can't believe that these conversations, you know, that you're talking about, haven't come up with the whole vibe coding community. Can you imagine? What'd you spend your day doing? I was chatting with Copilot, just getting everything all ready here. And it's like, do you know how much money you just spent? You just wasted every one of our tokens in one day. And I can't believe that this isn't an awareness.
But look how much I vibe coded, and there's only like 12 security holes in it. So, you know, hey, it's awesome.
I generated this entire code. Yeah, one thing that I think also applies to companies, and I'm not looking to open a can of worms here, but regulations are also here or really coming for companies that are looking to build such systems. And we know of certain initiatives, they're already being drafted and stuff like that. So companies developing these systems are going to have to tackle with that as well. And it's, you know, sometimes it's clear, sometimes it's a bit of a murky landscape, and they're going to have to invest in this, right? And it comes with additional, you know, consulting and legal cost and understanding things, plus the entire things that you have to do. You need to test and document and, you know, track experiments and findings and do risks assessments and stuff like that. So that's also something that I think sometimes deters companies from like fully going in on AI technologies.
I think this is a great point you bring in, because then I would say, how do we evaluate, how do we make sure that even from the development phase, the models that we're building are good, or they do what we intend them to do? What's your take on this? I don't know, Neal, feel free to go first.
Any sufficiently advanced technology is indistinguishable from magic. And most LLMs are just magic to most of us. I mean, there are actually patterns that are emerging for, you know, using a less expensive LLM most of the time, but then using a more expensive one to spot check it to see how well it's doing. So there are ways of you know, doing validations for those kinds of checks. But that's one of those things that's very case by case. There's because of the non-deterministic nature of these things. That's actually, and Birgitta, my colleague, is the one that lectured me about the spreadsheet metaphor. That's how it's fundamentally different, is that spreadsheets are deterministic. Can you imagine the chaos if spreadsheets started hallucinating tomorrow? The whole finance world would collapse. But we have to deal with the hallucination, so a lot of the certainty or the usefulness we put into these things is, how much can we trust what's coming out of the thing? So I think for certainly for the near term, trust but verify anything an AI tells you.
Mark, anything to add?
Yeah, I think it depends a lot on the use case, what we're actually using AI for. And I'll give you a good example of this evaluation process is, let's just take a simple thing of student test grading. We have a test. It's got true, false, multiple choice, or short answer kind of questions. Why are we having teachers and professors grade these things? We can have AI grade these. And that's a really cool idea. However, what about, let's say, something like a test or a certification, and you go in front of a certification board, you write your whole essay in short answers, and it's graded by AI. What do you think about that? I'm a little scared, because this is a certification, and if AI says, nope, that's wrong answer, I can't get that job that I'm looking for. And so one of the techniques, or several of the techniques in terms of these kind of use cases for AI, where we're actually having it evaluate something and give a result, are, as Neal said, using consensus in terms of, let's feed it into 3 different AIs and see 2 of them say pass and 1 says fail. Let's go with pass. The other technique is to periodically, or through a group of maybe every 10 tests are graded by a human, in other words, a professor, and AI, and those results compared. And hopefully this is done pre-production, but this is another way of doing this manual verification. This is the place we're at, everyone, where we do need to evaluate the results and see if it is correct, especially in cases where it's going to impact a human's life. And
well, this is a good example of how interesting this question is, because what you're suggesting is the way to make it better is to set more barrels of oil on fire.
oh yeah, absolutely.
Yeah, it's just that technique is useful because it saves a lot of time, but you're probably going to end up with some sort of a blend of various techniques. There are already, like open source frameworks or libraries that can help you set up evals, various evals for your LLMs. You can kind of like easily introduce that into some test suites and embed them into your CI/CD pipelines and stuff like that. The definite thing is that you do need to evaluate things. You do need to evaluate them pre-production. But I would also like to add that I think this is it's kind of like so working with AI and creating AI systems is kind of like a 24/7 war room kind of, experience. Like you're going to have to do that post-production as well,
Yes.
because a lot of things happen, right? So this is an ongoing work, right? So totally important to look onto that. And maybe if I can just add one slight twist to this is, whenever I think about evaluations, right, apart from the practical side, I do want to add that I think it's important not to think in terms of zeroisms when it comes to evaluating LLMs. Like, we're not perfect either, right? So we're also biased.
Speak for yourself.
Right,
for
so
yourself.
apart from that, right?
Beat
So,
me to it.
okay, I'm definitely. So we're also biased, and we have our own beliefs and our preconceptions, and we have our own things. There are cultural differences between us. There are, different experiences that we've lived through. And when we also make mistakes, regardless of what we do in life, regardless of our profession. So what I'm trying to say is that in the end, yes, things do need to be evaluated, and that needs to be a continuous process. But we're also going to have to get comfortable with a slight degree of, okay, this is not perfect, because this is also who we are.
I don't know why I never thought of that before. That's a really clever thing. Us humans are not perfect either, and we make mistakes, and yet we expect AI to be absolutely perfect.
Yeah.
And if we're trying to model human intelligence, it's going to be wrong sometimes,
It
as
is.
we are wrong
That's
sometimes.
exactly what it should do.
This is a really interesting
It just has to
thing
be
to ponder.
a little bit, like maybe close to your expertise or maybe slightly better, but it's never gonna be perfect.
I was going to ask you what's the best way to end this panel, because I did burn through my list of questions, but I think this is also a good way to look into the future and see, right, we're gonna use these tools, we're gonna build AI systems, and they're not gonna be perfect.
I think my parting words would be, everyone, please be cautiously optimistic about the possibilities we have with this technology. I showed you in the keynote on the last trend some really cool stuff, and it does work really well. I'm hoping that gives all of you some ideas for creativity and saying, we could actually apply this here and here. But just move forward with cautious optimism.
Yeah, couldn't have said it better. Well, I hope you enjoyed it as well.